Hi, hello everyone. So in this video, we're going to discuss this method known as trigonometric substitution. Okay, so as the name suggests, this is technically integration by substitution. However, yung gagamitin nating substitution is not really seen from the function. Kailangan natin gumamit ng special substitution kung saan gagamit tayo ng trigonometric functions. Okay, you can see here we have two tables. Yung una, kapag may integrals tayo na may mga ganitong forms, square root of a squared minus x squared, square root of a squared plus x squared, and square root of x squared minus a squared, we're simply going to use the following substitutions. X equals a sine theta, x equals a tangent theta, or x equals a secant theta, depending on kung ano yung nasa integral natin. Now, yung second table, it's actually a list of integrals kung saan ang antiderivative nila will be or will have inverse trigonometric functions. I will see later on why these two are very much related to one another. Okay, so let's start by solving this first example. Okay, suppose we want to get the antiderivative of the integral of square root of 9 minus x squared dx. Okay, I will just rewrite this as the square root of 3 squared minus x squared dx to make it little more obvious kung bakit ito yung gagamitin nating technique. Okay, so from the table presented earlier, if we have the square root of a squared minus x squared, ang gagamitin nating substitution is x equal to a sine theta. We have that the value of a is 3. So our substitution will now be x equals 3 sine theta. With our value of x as this one, if we get the derivative of x with respect to theta, this will be equal to 3 cosine theta d theta. We can now rewrite the integral as the square root of 9 minus 9 sine squared theta, then dx is 3 cosine theta d theta. Okay, this part here, it's actually 9 times 1 minus sine squared theta. And recall that 1 minus sine squared theta is cosine squared theta. So after writing it as cosine squared theta or 9 cosine squared theta and extracting the square root, we will actually get 3 cosine theta times 3 cosine theta d theta. Or, when we simplify, 9 cosine squared theta d theta. I recall from the previously learned technique, trigonometric integrals, we have that cosine squared theta is actually equal to 1/2 of 1 plus cosine 2 theta. So we apply this technique and substitute. So 9/2 1 plus cosine 2 theta d theta. We have 9/2 integral ng 1 plus cosine 2 theta d theta. Let's just separate the terms. 9 halves integral ng d theta plus 9 halves integral ng cosine 2 theta d theta. Okay, this part here is fairly easy to get. This one is 9 halves theta. And this part here will require us to use U substitution. Pero madali lang rin naman. All we have to do is set U to be equal to 2 theta and perform the rest of the steps. So doing that will give us 9/4 sine 2 theta plus C. Okay, notice no na yung sagot natin ay in terms of theta. Pero ang original natin was in terms of x. So we still have to rewrite this in terms of x. Parang pag nag-integration by substitution tayo, we have to write the final answer in terms of the original variable. Now, the question is, yung theta, paano natin i-convert to x? Okay? Recall na yung substitution na ginamit natin earlier was x equals 3 sine theta. So, by manipulation of this equation, we have x over 3 equal to sine theta. Okay? So, what now? We again have to recall yung ating SOHCAHTOA. Okay? Or yung relationship nung sides ng isang right triangle with respect to the trigonometric ratio used. Okay? So, sine is opposite over hypotenuse. So, what we're going to do is we're actually going to draw a reference triangle. So, draw a reference right triangle. Let's set this angle to be theta. Now, we're given that sine theta is x over 3. So, x over 3, that is opposite over hypotenuse. Okay? Opposite over hypotenuse. And then, we can solve for the remaining side by applying the Pythagorean theorem. So, applying the Pythagorean theorem, this is the square root of 9 minus x squared. Okay, so para saan ba yan? We're going to use this later on. Expand muna natin to. So, 9 halves theta plus 9/4. Then, recall that the double angle for sine is equal to 2 sine theta cosine theta. So, we can actually write this as 2 sine theta cosine theta plus C. Simplify. So, we have 9 halves theta plus 9 halves sine theta cosine theta plus C. Okay, and then we just simply write sine theta, cosine theta in terms of x. Okay, sine theta, it's already given from the substitution that we used. So we can simply replace it. We can replace this as x over 3. Okay, and then cosine theta, based on our reference triangle, cosine theta is the adjacent side over the hypotenuse. And the last is, how do we write theta? Okay, we simply have to solve this trigonometric equation. So x over 3 is sine theta. So this is actually arcsine of x over 3 equal to theta. So this is our answer. Of course, we can simplify. Simplify na rin natin. So these will cancel out. So 9/2 arcsine x over 3 plus x square root of 9 minus x squared over 2 plus c. And we treat this as our final answer. Okay, so it's a bit tedious, pero it allows us to solve these types of integrals. Okay, for our second example, let's consider this one. Okay, let's say we want to get the antiderivative of 2dx all over square root of 9 minus x squared. Okay, so i-rewrite ko lang to as 2 integral ng dx over square root of 9 minus x squared. Again, a is 3. So x equals 3 sine theta. And dx is 3 cosine theta d theta. With this, we can now rewrite this as 3 cosine theta d theta all over square root of 9 minus 9 sine squared theta. Okay, similar dun sa ating first example, this part here will actually be equal to 9 cosine squared theta, or square root of 9 cosine squared theta. So after simplifying, we have 3 cosine theta d theta all over 3 cosine theta. We can cancel these two out to get 2 times the integral of d theta, or that is equal to 2 theta plus c. So we're left again with how we write theta in terms of x. So it's quite simple kasi we're just going to use x equals 3 sine theta, divide both sides by 3, and solve for theta. So theta is arcsine x over 3. So we have 2 arcsine x over 3 plus c. Now, recall na we were presented with two tables. Okay, the second table contained a list of integrals kung saan given na agad yung kanilang antiderivative. Okay, from that table, we have that if our integral is of this form, du all over the square root of a squared minus u squared, this is arcsine u over a plus c. Okay, this one, of course, will mean that u is a function of x. So, kung ito yung gagamitin natin as an alternative approach, so we have 2 dx all over square root of 9 minus x squared. Again, a is 3, and we can simply assign u to be equal to x. So it satisfies this form of the integral. So pwedeng diretso na lang tayo sa substitution dun sa ating formula. Arcsine u over a plus c. Then of course, since may 2 tayo dito, we can write this as 2 times the integral of dx all over 9 minus x squared. So may multiplier lang tayo na 2 dito. Okay, so as you can see, parehas yung sagot na nakuha natin, which should be the case. Okay, however, dun sa second approach natin, it's just a much quicker way of getting the answer. Now, of course, it's not applicable to any type of integral. Kailangan ganito yung kanyang form. Okay? So, it's strictly applicable sa mga integrals na ganito ang form. Okay, let's consider a next case. Now, this time, let us solve the integral of square root of 1 plus x squared dx. So, sa ating table, square root of a squared plus x squared, we're going to use the substitution x equals a tangent theta. So, in here, x equals 1 times tangent theta. So, dx is secant squared theta d theta. So, this can now be written as the square root of 1 plus tangent squared theta. Then, dx is secant squared theta d theta. Okay? Okay, then recall from the Pythagorean identity that 1 plus tangent squared theta, this is equal to secant squared theta. So this part here is secant squared theta. Or after extracting the square root, you have secant cubed theta d theta. Okay, so we're left with this integral. Now this integral will actually require us to use integration by parts. Okay, so this part here will actually require us to use IBP. So recall IBP with u equal to secant theta and dv equals secant squared theta d theta. So I'll leave this to you as an exercise to verify that what we will get here is actually secant theta tangent theta over 2 plus 1/2 ln ng absolute value of secant theta plus tangent theta plus c. So again, verify this using integration by parts. Okay, so we have solved the integral all we have to do is rewrite this in terms of x. So similar dun sa ating first example, we're going to draw what we call a reference triangle, reference right triangle. And we're going to make use of x equals tangent theta. So this would mean that tangent theta is actually x over 1. If we assign this to be theta, tangent is opposite over adjacent. So the hypotenuse is 1 plus x squared, square root nun. Okay? So with this, we can now get the value of secant theta. Secant theta, this is hypotenuse over the adjacent side. So in this case, square root of 1 plus x squared all over 1. So our answer would be secant theta is square root of 1 plus x squared times tangent theta is x over 2 plus 1 half ln ng absolute value of secant theta is again square root of 1 plus x squared, and tangent theta is x, then plus c. So this is our answer. Okay, next example. Next example, suppose we want to get the antiderivative of dx over x squared plus 9. Okay, so dito, technically walang square root, pero pwede pa rin natin gamitin yung substitution na yun. Okay, so in this case, a is equal to 3. So x equals 3 tangent theta. With x being equal to 3 tangent theta, we have dx as 3 secant squared theta d theta. So this will allow us to rewrite the integral as 3 secant squared theta d theta all over 9 tangent squared theta plus 9. This part here will be equal to 9 secant squared theta. So with this, we have 3 secant squared theta d theta all over 9 secant squared theta. So secant squared will cancel out, and then 3 and 9 will just give us 1/3. So we have 1/3 integral ng d theta or 1/3 theta plus c. So we just again need to rewrite theta in terms of the original variable x. So galing tayo sa x equals 3 tangent theta. This would imply that x over 3 is tangent theta, and theta will be equal to arctangent of x over 3. Or, our final answer will be 1/3 arctan x over 3 plus c. So, do sa ating final answer, may inverse trigonometric, no? So, kung babalikan ulit natin yung ating second table that was presented at the start of the video, if we have an integral of this form, du over u squared plus a squared, this is equal to 1 over a arctan of u over a plus c. So again, here, u is a function of x. So do sa ating example, dx over x squared plus 9, u equals x, and a equals 3. So we have 1/3 arctan of u over a plus c. So, different approach, pero same yung sagot natin. Okay, now the last two examples will demonstrate yung substitution kapag secant naman yung gagamitin natin. Okay, so for example, we want to solve this integral. Square root of x squared minus 25 dx. So if we have square root of x squared minus a squared, we're going to make use of this substitution. Okay, so let x be equal to 5 secant theta. This of course would mean that dx is 5 secant theta tangent theta d theta. So we have square root of 25 secant squared theta minus 25. Then d theta natin is 5 secant theta tangent theta d theta. Okay, this one is technically 25 times secant squared theta minus 1 or 25 tangent squared theta. So after simplifying and extracting the square root, we're left with 5 tangent theta. So 25 secant theta tangent squared theta d theta. Down here, i-apply ulit natin yung techniques that were previously learned when we were solving trigonometric integrals. So rewrite this as secant squared theta minus 1 and simplify. Factor out ko yung 25. Integral ng secant cube theta minus secant theta d theta. Okay, so 25 integral ng secant cube theta minus 25 integral ng secant theta d theta. Okay, si integral ng secant cube theta, we have previously solved that. So this again is equal to secant theta tangent theta over 2 plus 1/2 ln ng secant theta plus tangent theta minus 25 integral ng secant theta d theta. Okay, secant theta, integral ng secant theta, we also know that. So, expand ko na to. 25 over 2 secant theta tangent theta plus 25 over 2 ln ng absolute value ng secant theta plus tangent theta minus 25 ln ng absolute value ng secant theta plus tangent theta plus c. We can combine these two terms. 25 over 2 secant theta tangent theta minus 25 over 2 ln ng secant theta plus tangent theta plus c. Now again, the last step is for us to rewrite this in terms of x. So we again make use of the substitution use. X equals 5 secant theta. Draw a reference triangle. This would mean that x over 5 is secant theta. Or, hypotenuse is x, adjacent side is 5. This would mean that this is x squared minus 25. With this reference triangle, we can solve for tangent theta to be equal to opposite over the adjacent side. Substitute the following values. Secant theta is x over 5. Tangent theta is square root of x squared minus 25 over 5. ln ng secant theta, tangent theta, plus c. Simplify. X square root of x squared minus 25 over 2 minus 25 over 2 ln ng absolute value of x plus 5 plus square root of x squared minus 25 over 5 plus c. So this is our answer. Okay, now for our last example, let's consider this one. So integral ng dx all over x square root of x squared minus 4. So we let x be equal to 2 secant theta. This of course will mean that dx is 2 secant theta tangent theta d theta. Rewriting this as 2 secant theta tangent theta d theta all over x is 2 secant theta and square root of 4 secant squared theta minus 4. Again, this is equal to 4 tangent squared theta or 2 tangent theta after extracting the square root. So 2 secant theta tangent theta d theta all over 4 secant theta tangent theta. So these will cancel out. May titira na lang tayong 1/2 d theta or 1/2 theta plus c. We again have to solve for theta. So from this equation here, we have x over 2 equals secant theta, or theta is arcsecant of x over 2. So we have 1/2 arcsecant x over 2 plus c. Okay, may inverse trig na lumabas. So again, kung babalikan natin yung ating second table that was presented earlier. So if we have an integral of the form du all over u square root of u squared minus a squared, this is equal to 1 over a arc secant of u over a plus c. So yung ating integral was dx over x square root of x squared minus 4. U is equal to x and a is 2. So we have 1 over A arcsecant of u over A plus C. Okay, which is the same as what we solved using the substitution. Okay, so this video can be a little, or this topic can be a little bit intimidating, lalo na since we have to recall our trigonometric ratios and trigonometric functions. But as long as we keep that in mind and we be careful with our solutions, kayang-kaya pa rin naman natin itong isolve.